Okay, hi everybody. This will be the sum and difference of symmetric matrices. So let me show you how does it work. I will begin to illustrate to you one by one in separate video. And in this video, I'll begin to give you the sum only. So for this one, if two matrices are and if two matrices A and B are symmetric, then their sum and difference will also be symmetric. So we'll begin to check that. Given that your sum A plus B, then you will begin to transpose the result, then it could be also is equals to the A plus B, A transpose, adding that to the transpose of B. We'll begin to illustrate that, and that is equals to A plus B as well. Since the transpose of A is equals to A, and since the transpose of B is equals to B, the sum remains symmetric. So we're going to check that later on. So the difference will be using the same A minus B, and then we'll begin the transpose it will still equate the same thing. And the transpose of A and transpose of B will still equate, and that must be equal to A or B. And again, since the transpose of A is equal to A and the transpose of B is equal to B the same, the difference remains symmetric for that. So let me just go ahead and give you a specific example for that here. Then for this sum first, I'll begin to give you the example for the sum. Say for example here then that we do have the A and B problem, 2, 3, and 3, 4, and 1, 2, and 2, 5. So for this one right now, we'll be going to get first that using this formula that this one here, we'll begin to use that first before even into consideration the other formula then. So we'll be going to do it step by step so that you could be able to get that one basically. So let's go ahead and take it one slowly. So for the A plus B, that must be equals to um 2 plus 1, 3 plus 2, 3 plus 2, 4 plus 5. So if you begin to calculate that one, it will equate to 3, then 5, then 5, then 9. So that will be the um result for this one. So that's for the A plus B. Remember, that is the A plus B yet because we were not able to transpose. So the transpose of that one right now, um, it will become 3, then 5, then 5, then 9. Since this will become the first column, this will become the second column. So by checking the two function, I mean by checking the two values right there, if you could be able to see that right there, that is definitely paving that if we could be able to observe in our result, that was the same thing, right? So that is a symmetric input condition. Yeah, first, since we were not able to get first the transpose of A, we'll begin to also check that in that particular example right now. So let me go ahead and walk you through as well for this transpose of A. We'll begin to transpose the A, then transpose to the B first and I'll begin to prove that one. So for the transpose of A, it will become this first column will become first row will become first column, second row will become the second column. So they are the same. Then for the transpose of B, first column or row will become first column, second row will become second column. So that is still the same thing. So when you will begin to calculate that right now, 2 plus 1, 3 plus 2, and 3 plus 2, then 4 plus 5. So it will become 3, then 5, then 5, and 9. So even that one, since if you begin to compare that in your, this will be the transpose of A and transpose of B. This is still the same thing. This is still the same thing. But for A plus B alone, you will not able to transpose that or any. Here we'll begin to 2 plus 1, then 3 plus 2, then 3 plus 2, then 4 plus 5. that will still equate 3, then 5, then 5, then 9. So considering the three results that you do have, they are equal, and that will prove that your formula right now is definitely your matrix is definitely symmetric. And I'll be going to illustrate to you the different example in the next video.